Welcome you all. In this session, we are going to discuss the unsymmetrical fault analysis, that is line to line fault, line to ground fault, and double line to ground fault. So, outcome after successful completion of this session, the student would able to analyze unsymmetrical fault such as a line to line fault, line to ground fault, and double line to ground fault in power system network. So, the first one is single line to ground fault. So before moving to the single line to ground fault, first let me brief out the short circuit analysis for unbalanced system. So here for the short circuit of an unbalanced system can be analyzed by the following steps. A few one or two steps are there. The very first step is you need to draw the positive, negative, and zero sequence network with their appropriate description. That is, if you are plotting a positive sequence means you need to represent each and everything in terms of positive sequence. The impedance values, everything in positive sequence. So if you are going to draw the negative sequence, then you need to represent everything in negative sequence components, and similarly in the zero sequence. The second step is you need to write the mathematical description depending upon the type of fault occurred in the system. So the third step is using Thevenin's theorem or bus impedance matrix determine the solution for the network equation. Fault current, post fault voltage are found at that point of fault at all buses and the line flows. Okay, so you need to calculate those values. So now let us discuss about single line to ground fault. So here you can see uh, the diagram which represents a single line to ground fault. So the A phase, B phase, C. You have three phases, A, B, and C phase. And here the fault occurred at phase A. It has been represented here by F. And the current flowing IA, IB, IC. We know that IB and IC are zero. Whenever a fault occurs to a particular system, the fault current increases rapidly. So here assume that A is small a is shorted to ground through impedance ZF, fault impedance A phases. Okay. Now the fault current is nothing but you need to calculate IA current. IA is nothing but the fault current IF. Okay, so here IB is equal to 0 and IC is also equal to 0 and VA is equal to ZF IA, because the Z, this impedance you need to consider ZF into IA. V is equal to I or IZ, isn't it? That is the formula. So now you are considering this fault impedance, so ZF into IA. And again IA is can be represented by IA1, IA2, IA3, that is the positive, negative, and zero sequence component, which is equal to by 3. So IA1 is equal to EA divided by Z1, Z2, Z0 plus 3 ZF. So this is how the fault current is calculated for. So here you can see the fault current is nothing but IA, but here we know the value of IA1. What's the relation between IA1 and IA? IA1 is equal to IA by 3. Therefore, IA is equal to 3 times IA1. Therefore, the fault current IF is equal to IA, which is equal to 3 times EA divided by Z1 plus Z2 plus Z0 plus 3 ZF. This is the fault current occurred when a single line to ground fault occurred. So here we have taken that we have chosen that A phase is faulted. So it is not compulsory A phase must be faulted. So depend upon the situation you need to choose which. So the next set is line to line fault. So when fault occurs between two line, that is what we call it as line to line fault. So now you can see it has been shown three phases, A phase, B phase, and C phase. And now you can see that the fault occurred between the B and C phase, and the fault impedance is ZF, isn't it? B and C phase, and the fault impedance is ZF. Is here the fault occurs between the B phase and C phase, and here A is undisturbed, right? So the current IA is equal to 0 and IB is equal to minus IC. You can choose that IB is equal to minus IC. Therefore, fault current IF is equal to IB, which is equal to minus IC. So you can, this is the fault current. It is enough to calculate either IB or IC, thereby you will be getting the fault current value, isn't it? So now, based upon the relations, IA is equal to 0, IC is equal to minus IB, and VB minus VC is equal to IB into ZF. VB minus VC, because so this is the potential difference between these two phases, right? B and C phase is nothing but the IZ, right? IB into ZF. And IA2 is equal to minus IA1, IA0 is equal to 0. So now I am substituting these values. VA1 minus VA2 is equal to ZF into IA1. So IA1 is equal to EA divided by Z1 plus Z2 plus 3 ZF. And from this, IB is equal to minus IC, which is equal to minus JEA divided by Z1 plus Z2 plus 3 ZF. This is the fault current. So IF, which is equal to IB, which is equal to minus IC. That is what we need. So the next set is double line to ground fault. Here the fault occurs between the two lines and to ground. So we name it as double line to ground fault. Here you can see A phase is undisturbed, whereas B and C is faulted towards the ground. That is why we call it as double line to ground fault. And here IA naught is equal to 0, IA1 to IA2 plus IA3 naught is equal to 0, that we know, right? So now VB is equal to VC, which is equal to ZF into IB plus IC. So which is equal to 3 ZF into IA naught. BA naught minus VA1, which is equal to VB, which is equal to 3 ZF IA naught. From this, IA1 is equal to 3 EA divided by Z1 plus Z2 into Z0 plus 3 ZF, the whole divided by Z2 plus Z0 plus 3 ZF. This is how we calculate the fault current in case of double line to ground fault. Unbalanced fault using bus impedance matrix. So now let us see how the bus impedance matrix. Single line to ground fault using Z bus. Consider a fault between a phase and a ground through a impedance Z at the bus K. For that fault current IK naught is equal to IK1, which is equal to IK2, which is equal to VK naught VK of 0 divided by ZK1, ZK2, ZK naught plus 3 ZF, where these Z values are the diagonal elements of K axis of Z bus, and Vk of 0 is the pre-fault voltage at that particular bus, K bus. Fault phase current IK ABC is equal to A times IK 0 1 2, that is 0 positive and negative sequence. Coming to line fault with the help of Z bus. So consider a fault between B and C phase through a impedance ZF. IK naught is equal to 0, IK1 is equal to minus IK square, which is also again equal to VK of 0 divided by ZK1 plus ZK2 plus ZF. That one is double line to ground fault. Similarly, here the fault considered to be occur between BC to ground. And so here IK1 is equal to VK of 0 divided by ZK1 plus ZK square into ZK0 plus 3 ZF divided by ZK square plus ZK0 plus 3 ZF. So IK square is equal to minus VK0 minus ZK IK divided by ZK square, and IK0 is equal to minus Vk of 0 minus ZK1 IK1 divided by ZK0 plus 3 ZF. So the fault current IKF is equal to IKB plus IKC. From this you can calculate the fault current for double line to ground fault through the impedance matrix, the help of impedance matrix. Bus voltages and line current during fault. Vi of F is equal to 0 minus Zi naught plus into Ik naught. Vi1 of f is equal to Vi naught of 0 minus Zik. And similarly, Ij is equal to Ij of 0, 1 and 2. 0 sequence, positive and negative sequence, which is equal to Vi of f minus Vj of f divided by Z. If it is 0 sequence, you need to represent all the 0 sequence parameters. If you are need the positive sequence, means you need to represent these all values in terms of positive sequence components. And if you want the negative sequence, then you need to substitute all those values in case in negative sequence. Thank you.